And it looks like we've had people join. I think Edwin joined. It's been a while. Welcome, Edwin. Charles joined. CS for All. I'm guessing Nick's joined. Welcome. And just for context, when you join, you're automatically put on mute. So if you are saying hello, we can't hear you.
Hey, everyone.
Hey, all.
How you doing, Mia? Kevin?
Hey, Charles.
Charles.
Thanks for joining. Hopefully everything's going well.
Virtually.
Yeah. And again, as promised, we are starting promptly today because we want to make sure we're respectful of everyone's time. I, for one, selfishly, biasedly, am really excited for what Kevin put together. We were going through it earlier this morning. I really think it's going to be extremely insightful and fun. So.
Well, that is the hope. Can everybody see my my first slide be a Swift Ninja? Are they seeing that?
Yeah, I see it.
Okay,
Yep.
perfect.
Yep, gotcha.
All right, awesome. We'll just wait another minute here.
As we wait that minute, just gonna remind everyone we are recording all of these sessions. Just so you know, we just keep it for our quality assurance and improvement, and it will only be used, well, it's gonna be used internally, but we are publishing it out so those who aren't able to join us can reference it in the future, as well as for you to reference when you work on that project afterwards.
Okay, well, it is 4 o'clock, so I guess I will get started. So thanks, welcome. I'm really excited about putting this series together, and I'm trying to make it, fun with the Swift Ninja thing and sort of working our way up and leveling up from some basic knowledge that you may have with respect to Swift and app dev, and sort of take on some of the topics that are a little harder to get your head wrapped around. They certainly were for me initially. And in teaching this in the past with other adults, it's definitely various topics are just harder than others. And so I want to help and make sure that you guys are comfortable when you need to teach this stuff in the app dev with Swift class. So just a few things about rules of the road. We will be doing a PD each Thursday at 4. And I have put out a list, which we'll look at in a sec, but we will start promptly at 4 o'clock each time. As Mia said, all the sessions are recorded. I do encourage feedback and interaction throughout the workshop. I only have a single laptop here at my house where I'm doing this right now. And so I can't do the full screen and Xcode and see the chat window all at the same time. So Mia's going to help me out here. So feel free to use the chat if you want to, or just feel free to, hit the space bar and interrupt and ask questions. That's fine. And if we get to the point where we can't move along fast enough, I'll just tell you stop and we'll just keep going and I'll come back to it afterwards. And then hopefully everybody saw in the Slack channel, including people that shouldn't have seen in the Slack channel, channel that's out there for the Ninja series is there for you guys to use and communicate with me and others that are going through the program. Our mission is really to raise the level of effectiveness and the proficiency that you have with Swift and app development using Xcode. So anything related to all of that in the context of you being able to be more proficient in the classroom and deal with 20 students all going in different directions and today's delegation and you're going, I completely forgot and have lost what this is all about. That's the reason we're doing these, so that we can sort of help you level up there. And by having them recorded and in a library, you can sort of go back and visit these things on demand as you need to. The series it currently is proposed to be along these lines. So we're doing delegation and protocols today. And I will tell you, it is one of the harder topics of all of the topics that are in this list. So again, as we go through this, if you are still a little confused, I will not take it totally personally, but definitely want to improve the PD so that you're not. But it is natural that this topic is one that it takes a little while to get your head wrapped around, and I'm going to try to do the best I can there. Objects and inheritance is planned for next week. Notifications and subscriptions, classes and structs. I won't go through all of this list, but suffice it to say, these are things that I think will apply in the classroom that you can take back and use as part of the class. But also, I want you to communicate with me about other things you would like to see. So none of this is etched in stone other than the first one, other than what we're going to do right now. And so I'm happy to reorder it if you know, oh, everybody's having problems with nil and optionals and stuff like that. We can make that the next topic if we need to, but I need to know sooner rather than later before you know, Thursday comes around. So just keep in mind, I'm here for you, and I'm here to hear what you want. But if I don't hear anything, this is the list. This is how we'll go through it. Okay, so just a quick thing of who the heck am I? So basically, I am a local Chicagoan, born and raised here, was graduated from Lane Tech in 1980. I also got my degree in computer science from IIT back in '84 in the dark ages, but I also have a digital electronics focus. When I graduated, I went to work for General Dynamics, which is now Lockheed, down in Fort Worth, Texas. And I did embedded avionics software for the F-16. And this is just kind of a funny picture. That's me on the right. Don't look anything like that anymore. I'm gray hair. I don't have curly blonde hair. But that's me standing next to an F-16 as we're working on something that go in there. So, and yeah, somebody probably should mute if you can. The cell phone. Okay. And then I've went to work for Rational Software, did a lot of consulting and embedded software development there. I then lost my mind and actually built a winery. So got into the wine business. So if anybody thinks they want to do that, I'm happy to tell them why they shouldn't. But ultimately survived that and am now back in the technical world. I've also been CTO for a company that this gentleman and I started, which was Glance, which is an internet connected smart mirror. So the idea is you get up in the morning and you stand in front of the mirror and groom, and it tells you about your day. Unfortunately, it wasn't successful. We couldn't raise enough money, but again, these are the types of technologies and things that I can do. And then Windy City Lab is the current incarnation of the company that I do development with. A lot of our development is in iOS. It's also in you know, server side work and a lot of embedded work. And as most recently have come on board with the being the CS curriculum design specialist for CECSE. So, you know, that's me. So let's just jump right into this PD number 1, delegation and protocols. And I have some primary objectives that I hope to achieve here. One is I want you to understand the core concept of what delegations and protocols are and when and why they're used. And basically, I've broken it down very prescriptively into 3 steps for what it takes to use a delegate and 3 steps for what it takes to be a delegate. So in delegation, there's always going to be somebody using it and then the delegate itself. And so I've got these 3 steps so that, again, when you're in the classroom and things are kind of chaotic and something's not working right, you'll be able to go back to these 3 things. If you do these 3 things on each side of the equation, the equation will balance and you'll have something working. And then we want to develop a simple app sort of using delegation. So I'm kind of a big, when a person, I love to use metaphors in thinking about how these things work. And so the metaphor that I'm going to use today is something related to a car, so GPS navigation in your car. And the one thing that's important for this metaphor to work, or this analogy to work, is that you don't consider it a self-driving car. This is not a car that's just going to take you somewhere on your own. And so one way to think about this is you have an individual, and this individual is driving the car. So they have this relationship with the car. They're sitting in the car and driving it. And they actually perform an operation on the car where they set the destination. So in that display up there in the right, you may see, punch in a destination that you want to go to. And so the person has interacted with the car in that respect. Now, as you're driving down the road, the car just on its own tells you that it needs to turn left in 300 feet. So this is something that is very critical to think about in the context of delegation and so forth, is that there are two active agents here. There are two parties at work. There's you, the individual that has a mind and is moving along and doing things on your own, but the car is actually doing things on its own as well. It's not just a passive thing that's only responding to you. It's actually, as it's going down the road, it's getting GPS information, looking at the destination you gave it, and now it's talking back to you. It's talking back to the user, the driver, and saying, we need to turn left in 300 feet. And so because it's not a self-driving car, the car isn't going to turn left on its own. The car is going to need you to turn the steering wheel to the left so that it turns. That's delegation. What the car is doing is commanding you. It's saying, hey, turn left in 300 feet. And it's delegating the responsibility of turning the steering wheel to the user. And therefore, the user then makes that, turns the steering wheel left, the car goes left. Then as you proceed down after you've made that turn, you get to your destination and the car now says, hey, you're at your destination. And that could mean, we need to stop. You're where you need to be. And so the delegate being you've been delegated the responsibility of reacting to this. You say, okay, I'm going to stop and I'm going to use the brake to do it. So you're telling the car how to stop. So the key here in this analogy or metaphor is that the person is the delegate. In fact, they're acting on behalf of the car based on what the car is asking it to do, because remember, it's not a self-driving car. And these two commands right here where it said, hey, turn left in 300 feet, or hey, you're at your destination, is what's called a protocol. And the protocol, all it really is saying is, how is the car going to communicate with you? That protocol could be, this could have been voice, could have been like a Siri assistant that says, hey, you're there, blah, blah, blah. It could be something that came up on the display up here on the right. But the point is that protocol is something that you, the delegate, know how to respond to. You understand it. If it speaks to me, I speak English. If it speaks to me in English, then we're good on the protocol. I know how to respond to whatever it is it's asking me to do. So just in summary on that, the protocol defines how you will talk to the delegate. So these things right here, the car is going to use this to talk to the delegate, and the delegate is the one who's going to respond to it. What you will see in a lot of the Swift nomenclature and in iOS is they will say a delegate needs to conform to the protocol. That's just a fancy way of saying respond. So you're conforming to the protocol. It means you know what you're doing. You know what you need to do. If it tells you to turn left in 300 feet, you know how to turn the steering wheel to the left. So you've conformed to it. So any questions on that analogy? Okay, so with that, what I want to do is contrast it with something that is very passive and doesn't need delegation. So in this scenario, we have an individual using a calculator. So this individual punches in some numbers and says, add up these numbers, and we get the numbers back. So we get the numbers back as a result. This calculator is not doing anything on its own. It doesn't have a life of its own like the car did. It's not going off and getting GPS information and coming back with it. It literally is passively just listening to whatever this user says to do. If you say add, I'll add. If you say subtract, I'll subtract. So the point is there's no reason for delegation here. This would be just an object in our system, and then we have something calling it and we get a result right when we ask it. We say, add these two numbers, we get a result back. There's no reason for delegation in this sense. Whereas with the car, we have reasons for delegation because the car is independently going off and doing navigational work and then asking you to do things to drive the car to where you're going to head to. Okay, so with that, we're going to jump into an app. So we're going to start coding and kind of see how this all fits together. And the app that we're going to do is basically a stopwatch function. And if you think about it in the context of what I just described, this stopwatch is not a purely passive object like the calculator. It's active. It's going to start ticking off time when you say go. And it's going to do that on its own. It's not going to need me, the user, to keep doing something every time. It will literally on its own start ticking off time. And so therefore, this is going to be something where delegation is going to play a role. When we start out, we're going to implement this without delegation initially and see kind of what the challenges are there, and then we'll throw delegation in to kind of solve it. So if we think about some of the operations that we would do on a stopwatch, one of them might be clear, right? So before you start the time, you want to clear it and set it to 0. Does anybody have any ideas on what another operation you would do on a stopwatch? And you can just unmute yourself and...
Stop.
Pardon?
Just stop it.
Okay, so stopping the time. What about, what's the reverse of that?
Starting the time.
Starting it. So you're going to start, you can stop, and you can clear. And the last thing is we want to be able to get the time off of the stopwatch and have the individual be able to see the time. So those are the operations that we're going to want to implement. So let's build our stopwatch app. And when I say let's, the thought is at this point, you guys will watch me code it up. I don't expect you to be coding with me in this. Depending on how these go and the time that we have and so forth, if we can do some of that, I'd like to. But I'm concerned that we may run out of time if you guys have to stay up with me. So I will go through this, and then of course you'll have a copy of the code. You'll have copies of the recording as we do it. So let's start with building out our stopwatch app without the delegation to start with. So in Xcode, one of the things I've done is I've already created a new project. It's just a single view application. And I've created a file for the stopwatch object class that we're going to declare. And then in our view controller, you'll see in a minute, I've put a couple of UI elements already in. The reason I did that is nobody wants to sit and watch me do all that when it has nothing to do with delegation and protocols, and it just eats up time. And I wish a lot more YouTube video people would do that as well, because I'll go to a topic and I want to get to the topic and they spend 20 minutes setting it up. So trying to avoid that here. So in this file, the stopwatch.swift file, we're going to create the class for the stopwatch. So essentially, we start out class, and we're going to give it the name stopwatch. And this is the type, this is the class which will actually become an object at some point. It will become the stopwatch. So what would be some of the things that this stopwatch needs to do based on what we just discussed in the slides?
Clear. Stop.
Yep. Okay. So we're going to do start. We're going to do stop. What else?
Clear.
Yep. Great. Clear. All right. Anything else?
Result.
So result. So now let's think about result a little bit, because that's exactly right. We need to somehow get the time back to us. So in thinking about this, this object needs to hold on to time. It needs to have an object, if you will, that's holding on to the time. So a variable. So we would say var, and I'll say current time. You can call this whatever you want. And I'm going to say, this is of type time interval, and I'm going to set it to 0. So all we've really done here is we've said, whenever we declare a stopwatch, we're always going to have this variable or property as a part of it called current time. And when this stopwatch comes into existence for the first time, the time interval, this current time, is set to 0. After that, it's going to be all completely dependent on what happens here. The other thing that this stopwatch needs is the actual ability to keep track of time. It needs to tick off every so often, whatever it is, every second, every 10th of a second, whatever that is, it needs to tick that off to keep track of time. And again, it's not part of this class, but it's kind of interesting to know that you can do this, and then you can sort of investigate these things offline. But essentially, I'm going to declare what's called a timer. And this timer is also a property of the stopwatch. And this, with a capital T, is actually a special class in Swift and in iOS. And so what this is this is a timer that we can operate on. And this is a timer that will tell us when something happens, when it ticks off a certain time, like a frequency. So what I'm going to do is I'm going to jump over here to just grab the code for this. But if we look at the functions that we have here now, which is the one that you think is the one that we need to create the timer, actually initialize it and get it going? Is it in start, stop, or clear?
Start.
Start, exactly. So you could do it in clear as well, but start would be where I would start. So essentially what I've done is I've pasted in here the code. And again, it's not important for this tutorial as to all the details of this. Just suffice it to say that this timer has various constructors or initializers. There's various ways that you can create timers. And one of them is called a scheduled timer. So this timer with a scheduled timer, the parameters are, one is with interval. So that's saying, well, okay, we're going to start a timer and we're going to have an interval. In this case, the argument, if you read the docs, is in seconds. So this is 0.1 seconds. So this is every 10th of a second, this time interval is made. And then the question, next one is it going to repeat or not? And we want it to repeat. So it's a stopwatch. So we want it to keep going every 10th of a second. Don't worry about the block stuff here. That's a whole nother class at some point. But right here, this is the important part. Right here in this timer, we actually, this line of code will actually execute on its own every 10th of a second. So once you get this timer initialized right here, iOS is going to do this for you. It's going to call this again and again and again every 10th of a second. So what I'm doing here is I'm taking the current time, which started out as 0, and when the clock ticks at a 10th of a second, we are going to add 0.1 to current time. So every time this happens, current time is going to increment by 0.1. Any questions on that? Do people feel comfortable? At least they understand it. I'm not concerned about, all of the syntax of this. I just want to make sure that you follow that when we call start, this timer gets initialized, and from then on, this guy's going to get called. So there's one other nit that
Hey, Kevin, sorry,
yeah,
this is Mia.
sure.
I just want to make sure that I have this right. So right now, just to confirm, we're just building the structure of the timer app.
Correct.
Right. We're not, okay.
We're not in delegation yet. Right. So what we're doing is we're building up the stopwatch object. And so we have basically, this is the object that we're building up, and we're implementing these operations on that object.
Great.
Okay. So one other thing we want to do here is we want to, before we actually create the timer, we want to do something which is, in their method, it's called invalidate. And what this does is if a timer is already running, we invalidate it or get rid of it, and then we create a new one. And the reason we do that is this. If you were to call some other set of code, which has created this stopwatch, decided to keep calling start over and over and over again, it would literally create that many timers all in parallel. You would end up with 1,000 timers if you called it 1,000 times. So to prevent that, what we do is if a timer is already running, we invalidate it and then we create it. And what that does is we'll never get more than one. And we only want one because it's only one stopwatch. Okay. So if this sort of gets rid of the timer, what do we think we put down here on line 15 for stop? How do we stop the timer?
Would it be the same thing?
Exactly. Yes, it's the same thing. We're just going to invalidate it. So I'm going to just copy this line down here, and now now the timer will be stopped. And anybody want to venture? So how do we clear the current time?
Invalidate all.
I'm sorry?
Invalidate all.
So there's no invalid. So this is the thing that we're trying to set to 0. So the timer is going to keep running. I don't know if if you think about like last time I used a physical stopwatch like that is if you had it running and you kept hitting the clear button, it would clear to 0, but it would then go back and keep running again. You know, it would always just keep running. So what we're wanting to do here when we clear, we're wanting to clear this variable. We're wanting to clear that current time back to 0. So if this guy's running, it's going to start, ticking up in time again. Essentially what we want to do here is just say current time equals 0. So by doing that, what we've done is you hit clear, it will go down back to 0, and you're good to go. So this is literally right now the implementation of the stopwatch. Okay, we have a way to start it. We've got our timer that kicks off. The current time will keep incrementing by 0.1 every time this is called. If you click stop, we'll invalidate the timer, but we don't clear the current time. So it'll just stop and it will keep that time that you want. But if you come down here and hit clear, you'll clear it. So now let's go to the view controller or the storyboard for a minute. So in the storyboard, what I've done is I've created this already. So there's a label here that's meant to show the time that's on the stopwatch. And then we have a start button, a stop button, a clear button, and a show time button. And all of these buttons have already been, had IB actions or IB outlets created for it. And you'll notice one of the things I do as a typical standard with development is if this button says start, then this function should say start tapped. If this is stop, this is stop tapped. It's very nice to keep those synchronized together, keep the naming together. It's not required by the language, but it's considered kind of good practice. And we have our label here, and we have the current time label. So what we want to do is this view controller needs to have visibility to the stopwatch, and so it needs to create a stopwatch and then interact with it. So we'll create the stopwatch up here by saying my stopwatch, and we can just say equals stopwatch with open and close paren. So what does this do? Anybody have a thought as to what that statement does?
Does it set up an instance of the class?
Exactly, that's exactly right. So this is now an object, and we've taken an instance of this class stopwatch, which just has a base constructor. Base constructor just means, you don't have to give it any parameters or do anything. You just have to put the two parentheses there, and now we have a stopwatch. And I will typically do my stopwatch. It's like my label, my this, my that. But that's just a developer style that you have to decide, what you want to do there. So if we have a stopwatch now and they tap on the start button, what should we do? What operations can we do on a stopwatch?
Start.
Yep, exactly. So here we would say my stopwatch dot start. So when we tap on the start button, we actually call start on the stopwatch. What would we do here for stop?
Call stop.
Yep. And what would we do for clear? Clear.
Clear.
All right. And now show time tapped. So what this means is you're tapping the button and we want to get the current time from the stopwatch into that label, this current time label right here. So does anybody remember on the left-hand side of this equal sign, if you will, current time label, how do you actually set a value for a label? Do we remember?
Current time level dot timer.
Almost. So current
dot.
time. Yep. Current time label. And you
Dot.
can't I can't just say this, right?
Yeah.
Because that's the label. But there's one more thing here at the end.
Shoot. Timer. Gosh.
No timer yet. So this would be current time label dot text.
Oh, text. Okay.
Yeah. So all of your labels have a property called text. That's what you're going to set to. So now I could say, oops, I keep hitting the wrong key. If I hit foo here, literally, if I hit the clear button, the word foo is going to come up in it. Let's try it. Right. So if I say clear, didn't do it. Current time label dot text. Oh, show time tapped. Sorry, I put it to here. So show time tapped. There it is. Foo, right? Because the text disappeared. But foo is not what we want. We want the actual time off of the stopwatch. And the way we can grab that here is with this form of code, which I will pop in. So
cool.
Essentially what this does is it's going to look at my stopwatch and it's going to grab the property current time. And then this thing is just a way to format it so that we don't get this huge number with a bunch of zeros and so forth. This is just a common, you can look these up or Google them, all the different formats that you can use. And that will format it, okay? So when we run this now, and we haven't started it yet, what do we think we should get in label if I do show time?
Current time.
0.
Right, current time. So there it is. It's a 0, okay? So now if we click start, I don't get any indication that anything's happening.
Right.
But if I click show time, I get a 7.8.
Yeah.
If I click show time again, I get 12.8. So the stopwatch is running. It's just we're not getting any updates here. What if I hit stop? So now if I hit stop and I do show time, okay, that was the time between the last time we did show time and hitting stop. But now if I do show time again, I'm not getting anything, right? Nothing's changing because the stopwatch has stopped, right? And then another thing here is clear. If I click clear, well, I don't see anything here, but if I do show time, sure enough, the clear function worked. Okay. So we have sort of a app. It's not a really very good one, but it's actually exercising the stopwatch. So the question that I have for you is, what is the problem with our app at this point? Why would I say it's not great?
It doesn't show elapsed time.
Exactly. That's right. So we would want this to be much more dynamic. When I hit start, I should see things flying along here.
Yeah.
And when I hit stop, I should see it stop, right? And if I hit clear, I should see it go to 0. You know, I shouldn't have to do this showtime the whole time. So that's exactly right. So this is where delegation is going to come in. So when we add delegation, what we're missing right now in the view controller is we don't know when the time has changed. That's why hitting the showtime button, you just poll it. You just keep hitting it. It's like going to the telephone to see if it's ringing all the time. You know, it's like, or somebody's on the other line. So what we want to be is notified that the time did get updated. And so that is where this comes in. So this is a protocol now that gets defined against the stopwatch. So the stopwatch is saying, hey, whoever is my delegate, I am going to call time did update. And I'm going to call that every 10th of a second. And when I do that, I'm going to call it on the delegate. And then the delegate can say, oh, the time got updated. I better go update the label, right? I better update the label with the latest time. So what we're going to do is go put this and implement that piece of it so that the stopwatch can talk back to the view controller. So in this scenario, what we have is we have this initiator, which is a person that's just hitting buttons on the view controller. And as we did that, there were calls made to the stopwatch, and maybe there were return values that came back, maybe not. But this is what we have implemented right now. Now, what we want to do is have the stopwatch have the ability to talk back to the view controller. The stopwatch is this active object that has its own life and it's doing its own things. And we want it to talk back to the view controller and tell us all about itself and what it's doing. It's going to do that via a protocol. And we may or may not get return values when we do that, but it's talking to the delegate here. And then the only last thing I add in this slide, the reason the stopwatch is this active object that's off doing its own thing and it's on its own is because iOS is the initiator here. So just like the view controller, where I as an individual am the initiator hitting the buttons on the view controller, here iOS is actually initiating the timer and it's taking care of that. So how do we use, so the stopwatch needs to know how do we use a delegate, and for the view controller, we want to know how to be a delegate. So let's jump into that. First thing, these are the 3 steps that you're going to use a delegate. The first thing you want to do is declare the protocol. And what this means is, what does the object want to tell or ask of the delegate? So let's go back into here, to the code. We're going to go back to the stopwatch. And up here at the top, above the class, we are going to define a protocol. And we do that by typing protocol. And then we're going to give it a name. You can give it any name you want, but the standard or the suggested way to do this is to call it stopwatch delegate. Now, this is where the fact that Apple did this for many, many, many years, to me is poorly named. This is a stopwatch protocol. I mean, after all, it is right here declared as a protocol. This is the protocol that you are going to use when you talk to a delegate. It's not the delegate. It's how you're going to talk to the delegate. But I'm not going to do that because the standard is always to name it this way. So what you'll do is you'll take the name, the class name, and just reuse it and add delegate to the end. And then we want one of the functions. So if we go back here to this, we said that the stopwatch was going to talk back to the delegate and call time did update. So in here, that's what our function is. So we say func time did update. So at this point, we've declared the protocol. And what's interesting about this is that you don't, over here with the stopwatch, we're not implementing this. We're just saying that somebody else has to implement it later. All we're saying is they need to do this because we're going to call it. Every second or every 10th of a second, we're going to call this. So do with it what you want. But that's part of the protocol. So that's, let's get back to where our steps were here. So that's step one, time did update. So we've just implemented the first part. Now the second part is declare the property that will point to the delegate. So what that means is if we're here in the code, I, as a stopwatch, need to have a handle or a way to talk to the delegate. The delegate in this case is going to be the view controller. So we could say var delegate, and the delegate is based off of this definition of the protocol. So we copy that down here, and we have now declared a variable called delegate. It doesn't have to be called delegate. It could be called foo. It's just a standard that we say delegate. But this does need to be what this protocol is up here. So we have the delegate declared here, but it hasn't been set. And that's because whoever is going to be the delegate, that's their job to set this. This one, the stopwatch doesn't know who the delegate's going to be. It's just like the car. The car knows that there's a person that's going to drive the car, but it doesn't know who it is. You know, it could be Mia driving the BMW, it could be me, it could be Amy, it could be anybody. So in the same way, we don't know which view controller is going to become the delegate. All we know is that we need to have a handle to it. We need to have a way to point to it or call it. So that's the hook. And then the third thing is, hey, we need to use this. So if I've got this thing here, but I never call it anywhere, then there's no point in using it. There's no point in it being there. So if I look at this code, where is the best place to call time did update? So let me ask it a different way. When would I call time did update?
Would you call it right after you increment it in the start function?
Absolutely, right here. So because this is when it's updating. We're updating the time there on line 16. So we're now gonna say self.delegate.time did update. So we can't just call time did update directly. We're calling it on the delegate. Whoever has come in and said, I'm the delegate, I'm responsible, you know, send those messages to me. Once they've done that, then this will get called, and it'll get called every time, and they will get a notification for that. So at this point, those are the three steps. It's declare the protocol, it's declare the delegate, and then use it. Use it however you want. Use it all over the place, you know, whatever. And this can be more than one function. This could be 10 functions or 100 functions or whatever. You know, the protocol can be as, you know, as expressive as you want. So now in the view controller, we go back to the view controller. So in our slides, now we're going to be talking about the 3 steps of being a delegate. So this is not going and using the delegate, but now I am the delegate. So the first thing you have to do is the delegate must declare itself that it's going to use and conform to the protocol. So it's like raising their hand and saying, I know how to drive. If the car tells me to turn left, I know how to turn left. If the car tells me to stop, I know how to stop. So what's going on here is the view controller must declare that it knows how to do the things that the protocol has said it needs to do for the stopwatch. So does anybody remember, like if you look at this syntax on a class, what does this mean when they have UI view controller there? So what this means is that it's inheriting this view controller, which again, this name could be foo, does not matter. It could be anything we want. This view controller inherits from UI view controller. So it inherits all of the capabilities that iOS has put together for a view controller. And that is a normal way of doing inheritance. Now, we are not inheriting from the stopwatch. We're not becoming another stopwatch. We're just getting access to the protocol. And literally the way you do that is you just say comma here, and you say stopwatch delegate. This is again why I wish it was named stopwatch protocol, because that's what you're getting. You're basically, you are stating when you do this that I am going to implement that protocol. I am going to respond to what that stopwatch tells me to do. So that is the first step. Now, the next one is to conform to the protocol. And all that means is you're going to implement each of the methods in the protocol. And so what's cool about Xcode is over here, it's saying, hey, silly, you said that you're going to do this. You're going to conform to the protocol, but you haven't actually implemented any of that. It's not in your code. And so you can click on this button and say, it asks you, do you want me to add the stubs for you? Stubs are just sort of placeholders. So you hit fix, and it added time did update for you. So it put it in. It said, you know, you've got to, you told me you're going to conform to this. Okay, here's the function. Now you go do it. So I guess the question now is, what should we put in this function? What do we want to do every time the time is updated?
1/10 of a second.
Right, 1/10 of a second. So that 1/10 of a second from the stopwatch is going to be recorded. And what we want to do is basically display it, right? So in that 1/10 of it, now that we know that a 1/10 of a second has gone off or that the time has changed, we want to update our label to show that new time. So I'm just going to grab this code where we had show time and just put it right in here. So what happened is time did update, gets called, and what do? We say, hey, stopwatch, what is the current time? And we put it into the label. So we've done two things now on this list. We said that we raised our hand and declared that we are going to do that function, and then we did the function. So we did this, and we did this. So trick question, do we think this is sufficient, and do we think this is going to work? So if I hit, let's go ahead and hit run here, and I hit start, nothing is happening. And the reason I'm making a big point of this is every iOS developer's life. This will be the kids when they're working with a UI kit that has a callback, has a delegate, delegation as a part of what they're dealing with, like table views as an example. The classic scenario is I did everything right and nothing's happening. And the reason nothing is happening is because we never did step 3. So step 3 is set the delegate to be self. So here's what this means, is in Xcode, right here in view did load is typically where I would do it. We're going to go, you're just going back to the life cycles that we have for all of the different, you know, a view controller goes through life cycles. It'll start out view will load, then view did load, then view will appear, then view did appear. So view did load means that it just loaded the view controller into memory, but it hasn't displayed anything yet. So this is a good place to put other initialization things. And what we're going to do here is we're just going to say my stopwatch dot delegate. So that's the object that the stopwatch is looking to talk to. equals self. So when this initializes, we tell the stopwatch that the self is basically referring to this view controller. It's referring to this object. It's saying, hey, I'm the delegate. It's saying, hey, stopwatch, I am your delegate. So now when we run this and we hit start, all on its own. If we hit stop, it stops. Why does it stop? Because when we hit the stop, it calls the function stop, which invalidates the timer. And this timer is no longer firing, and it's no longer calling time did update. And so our view controller doesn't get any more notifications, and it just leaves the last value that it had. Just leaves it there. So here's a little interesting thing too. If I hit clear, what do we expect to happen here?
0.
Yep, that would be what you would think. The user would think that. So I'm going to hit clear, and it didn't clear. But it really did clear. It just didn't display it here. Because if I hit start, you'll see it starts over again.
There's no code to clear the count.
Oh, good. So let's look at that. If I go down here to the stopwatch, or let's go back even to the view controller. And I look at clear, it looks like it does call the my stopwatch clear function. So we go to the clear function for the stopwatch, and it looks like it sets the current time to 0. But what is it not doing here that it needs to do?
Not displaying it.
It's not displaying it. So remember, the stopwatch doesn't really know anything about a display. It's stupid in that respect. All it knows is its protocol. It didn't call time did update. It didn't call it. We're calling it every time we update with the timer, but we didn't call it here. So the view controller has no idea that current time got set to 0, and therefore it doesn't update it. So what we would do is we would add it here. We would say delegate dot time did update. So you just keep in mind, the delegate doesn't know unless this is called. So if you're manipulating the time here, and you're manipulating the time here, and you manipulated it somewhere else, you need to call this time did update for the delegate to know that. So now when I run this, let's go ahead and hit start. Go ahead and hit stop. And if I say clear, it goes to 0. It goes to 0 because now we told the delegate that something happened. So again, it does take a little while to get your head wrapped around, because you're really, you're going backwards. You're sort of, the view controller talks to the stopwatch, but the stopwatch talks back to the view controller as a delegate. So in review, I'm going to take you through using a delegate, and we'll just slide in some code here. In the class stopwatch, the first thing you're going to do is you're always going to declare your protocol. So that's step 1 in using a delegate. You're going to say, here's the things I'm going to communicate to the delegate. That's the first thing. The second thing is you're always going to add the delegate variable. The delegate variable is how you're going to hook up to whoever the delegate becomes. And then the third one is you're going to use it. So you need to do time did update if that's what your function is here. If you never call it, nothing's ever going to happen. So you're going to call it in all the appropriate places. And that's really up to the designer of this object. So those are the 3 steps. The 3 steps to becoming a delegate are the following. First of all, this view controller has to raise its hand and say, I hereby declare that I am going to comply with, conform with the stopwatch delegate protocol. And it does that by adding this comma and this term here. The next thing it's going to do is it needs to actually conform. This is saying I will conform, but this is actually conforming. So now we've actually implemented a function, timed it update. And this was the function, the code that we did for that. And then the final thing, the big one that everybody forgets, which is why I just want to reinforce when things don't work, check this, is they did not set the delegate to self. These animations, if you go past, you're stuck. So here you have stopwatch.delegate equals self. That allows the stopwatch to communicate with the view controller. This is the view controller, self. It's referring to itself. We're in view controller here. So those are the 3 steps. You have 3 steps on one side and 3 steps on the other, and you get communication going that way. So any questions? I'm almost out of time, but I actually think that timed pretty well. So here's the homework. First of all, I would like you to do what we did. So basically, you're going to create a single view application project and basically implement the stopwatch example as we have done using delegation. But I want you to improve the user experience by disabling and enabling the appropriate buttons using delegation. So here's what I mean by that. Right now, if I click, all of these buttons are enabled. And let me ask you a simple question. Is the stopwatch currently running?
No.
No. So why would I have a stop button enabled that I could hit? I might want the stop button to be disabled. Now, when I hit start, it's running. I shouldn't be able to hit start again. It's already running. So I want the start button to be disabled when it's running. And I want the stop button to be disabled when it isn't running. Disabled when it isn't running, right? We'll always have clear. So if I hit clear, it just clears it, still running. But you get the idea. It's just and you can look up how to set the button to a disabled state. It's pretty easy. So the thing you have to think about is, how am I going to know if it's running or not? All I know right now is I get notified every time it changes, but I technically don't know if it's running or not. So the way you need to do that is you need to add a little more into your protocol. Add a couple new functions that will tell you that. And then when down here, when you say stop or you say start, you call those functions. And then you listen for them on the view controller side. And that gives you the ability to manipulate the enable and disable. So again, I think until you do it, you will, it's a tough concept, but it's why I wanted to kind of put this together and put it out there for everybody. We only have about 3 minutes left. Definitely ask questions. Feel free to ask them in the Be a Swift Ninja channel, because I think everybody can benefit from the questions and the Q&A. But also feel free to email me at kevinmcewen@northwestern.edu as well. And the goal is for you to just basically take what we've done here, add a little more capability for disabling, enabling the buttons appropriately. And you're going to want to use delegation to do that, which I just kind of described. And we'll go from there. I see some stuff maybe coming up in chat, but I can't see chat.
Yeah, sorry, Kevin. I was just about to hop in. Just wanted to reiterate that we are going to be following up an email, one to share the slide deck, and then also share Kevin's email address, again, contact information, and then those follow-up steps regarding the homework and project-based assignment.
Yep.
Kevin, people are basically saying, thank you for the introduction. It was great.
Awesome.
Sarah humbly said that she's a noob. She had a little bit difficulty keeping up. But Sarah, we're here for you, and we're going to be following up with some supports. And Kevin, if I'm going to throw you on the spot, potentially 30-minute office hour, maybe Monday, just to see if how people are doing and if they want to
absolutely.
ask any questions.
You bet. And don't, I can do the open office hours, but I also can be very just reactive. So just, shoot me, hey, I need help here or whatever. And if you're stuck, you can zip up your project and send it to me if you're not a GitHub person. We may do something on GitHub at some point, but I'm here to get you unblocked. Not here to give you the answer, but.
Awesome. Well, with that, Kevin, you want to sign us off?
Sure.
Awesome. Thank you, everyone.
Thanks, everyone.
Thanks, everyone.
Thanks, Kevin.
Thank you. Appreciate it.
Thank you.
Thank you. Bye-bye.
Bye.